Got to give the people, get the people what they want. People want a short video. People want to get these special factorings done, and they don't want to have mistakes all in the video. So I'm going to get all that. Mr. Bass right here, 2022. Let's get it. Write this stuff down in this part. All right, so we got some special situations that we factor. The first one, in this one, you need to memorize. It's called a difference of squares. A squared minus B squared. When you're factoring it, if you see that that little pattern, it always becomes A plus B times A minus B. So let's talk about what that means. Check out this example right here, okay? So 9x squared is a perfect square because this would be your A situation, right? 9 is 3 times 3, so I could take a square root of 9. X squared is a perfect square. The square root of that is x. So 9, this would be my A squared term. So A would be 3x, because 3x times 3x equals 9x squared. This would be my B squared term, right? Because 25, the square root of 25 is 5, and the square root of y is y. So if A squared is 9x squared, B squared is 25y squared, A is then 3x, the square root of this, B is then 5y, the square root of that. Hopefully that made sense. So now, if I see this, I just need to do A plus B to factor this initial problem right here. And I'm going to get rid of some of this crazy writing. We'll just put back B being 5y. To factor this, I just go, well, A is 3x, B is 5y. So to factor 9x squared minus 25y, that would equal A plus B, 3x plus 5y, times A minus B, 3x minus 5y. All right? It's going to be really important that you write down what A and B actually are. I know it seems trivial and silly, but it's going to help you in the long run. All right, this top one, the difference of squares, you need to memorize. You need to just know this when you see it and remember it's A plus B times A minus B. These next two, the sum of cubes and the difference of cubes, you do not need to memorize them. You just need to know how to use them if you're given the formula. All right, so the sum of cubes is A cubed plus B cubed. And if you ever see that, that means A plus B times A squared minus AB plus B squared. We're going to do the same idea. Here's A cubed, here's B cubed. Because I can take a cubed root of 8. What number times itself 3 times equals 8? That's 2. What letter times itself 3 times is x cubed. That equals x, right? 2x times 2x times 2x is 8x cubed. Here is my b cubed, right? What number times itself 3 times is 27. 3 times 3 times 3 is 27. So the cubed root of 27 is 3, and the cubed root of y cubed is y. So now in this situation, A is 2x and B is 3y. So now I'm just going to follow again. As soon as I know what A and B are, I can just plug into this formula. So I know A cubed plus B cubed, which is 8x cubed plus 27y cubed. That equals A plus B, 2x plus 3y. A and B. A squared, I'm going to take 2x and square it. In other words, 2x times 2x, which is 4x squared. 4x squared minus A times B, so 2x times 3y, which equals 6xy, minus 6xy plus B squared, which is 3y times 3y, which is 9y squared. I just figure out what A and B are, and I plug them into the equation. Last one here is a difference of 2 cubes, right? I see a perfect cube of x cubed, and I see a perfect cube of 64. the cubed root of x cubed. So the a term, if this is a cubed, then a is x. If this is b cubed, the cubed root of 64 is 4, because 4 times 4 times 4 is 64, right? And now I am just plugging into the formula. So x cubed minus 64 equals, right? Perfect cube minus a perfect cube equals a minus b. So it's going to be x minus 4. A squared, x squared. AB is a times b. Well, x times 4 is 4x. And b squared, 4 times 4 is 16. Boom, there it is. That's it. There aren't any mistakes this time. Bass, I'm out. We're going to do it tomorrow.